client is initiator, server is responder. The app perf tab actually will tell you up here at the top right who was the client, who was the server, and who was the initiator. You might say, well, isn't the initiator always the client? There are exceptions, FTP maybe, and a couple other situations where the initiator might be different from the client, but not usually. Now for UDP, what we do is just the very first packet that starts the flow, this right side is the server and the left side is the client. So for scoring latency stats on UDP, we simply watch the first packet and then watch the second packet, start, stop timer, and work out the UDP latency from just the first exchanges in the flow itself. For TCP, you have a little more information because you have the SND states or the TCP flag states that you can use as references for which sequence a particular packet occupies in the flow. But the main idea here is that, and I want you to remember this color, anywhere in the product that you see this orange color, that's client side. And where you see this bluish color, that's server. So for all of these reports we're going to look at and talk about, client is orange and server is blue. Let's talk about what these individual measurements are and what they look like, what they mean, where we show them. So the most important one I would say is total delay. This is round trip time. You might also call it latency, although some people consider latency to be one direction, like how long it takes packet go from A to B, not A to B back to A. This is how long it's taken packets to travel from where you are to the other end and come back again. And it's supposed to be a measurement of the network itself, not so much how long it took the other device to process the request and send it back to you. This is also what you would see if you were to ping something. So if you just say, ping 105021.243, and you're using PS ping, so it's TCP, this number is what we will show you in the UI. That is the total delay or the latency. So we break up the total delay into two subcomponents, the client network delay and the server network delay. So the client network delay is the area of latency between the EdgeConnect and the client side of the flow. The server delay is from the EdgeConnect to the server. Let's say this client here is opening a connection to the server on the right. In the EdgeConnect, we will represent 10 milliseconds for this side and 60 on this side for a total of 70 milliseconds round trip or total delay. It breaks it up in that way. And so we've brought that forward in the UI and through the coloring and everything and through the reporting, because what you end up with is a situation where you can independently isolate LAN side latency, in particular wireless latency. You can discreetly see it in the UI as typically the orange portion of the chart, and it ends up being very useful. So imagine I have a client at the bottom, and he's going to open a connection across his local EdgeConnect, across the fabric, through another EdgeConnect, maybe a hub on the other end, out the hub's LAN side to a server, and the server is going to respond back again. On the bottom EdgeConnect, on the branch EdgeConnect, the CND, or the network to client delay, is tiny. It's like 2 milliseconds. It's because it's its physical connection. It should be in the range of like 1 millisecond, almost unmeasurable. The WAN side is the majority of the consumption here. So we've got the network to server delay of 21 milliseconds. The total delay is the network to server plus the network to client. This is the whole thing, 23. We get 21 for server and 2 for client. And so if you go into the flow details and you click the flow details button, and then you click the app perf or performance tab, you'll get this little table, and it will lay out each one of these stats for you. So on the hub side, we have a different story, right? These stats are being recorded in a different context. So if I'm the hub, there's more time spent sending the packet along the client portion to the hub, and then the hub sees the server portion as very small, because in this case, the server is on the LAN side. Now, there's all kind of variations. Like for instance, I could get to the hub and I could hairpin the traffic back out to Zscaler, for instance. I could have a lot of client delay and a lot of server delay. Now, armed with that information, we can have even deeper discussion about these colors and the context and what they mean. Does orange and blue map to LAN and WAN? And the answer is sometimes, depending on the context. So imagine we're looking at the branch office and we pull up the application performance summary view and we just look at all the flows. For a branch office, you will typically see a lot of blue because Most clients, which are orange, are on the LAN side. Most servers, which are blue, are on the WAN side for a branch. And so in this case, orange will roughly equate to LAN side latency. Blue will equate to LAN side latency. And you can see that here. There's small amounts of orange with mostly blue as the dominant portion of the latency. You could have an inbound port forward, for instance. At the branch, you would see more orange and then just a little bit of blue because the server's on the LAN side of the EdgeConnect itself. Now, again, when we switch to the server, the whole thing kind of it changes because at the server it's all flipped around. If you just let's assume that you have like a server that's a cloud on ramp. Most clients at the hub are on the WAN side. They're on the fabric coming in to the hub, and then in that case, most servers are actually technically also on the WAN side, but can be on the LAN side if you do LAN side drain. So blue will typically equate to the LAN side portion, and orange will typically equate to the fabric or the WAN side.